Hello and welcome back to the Kid Chemist. The goal of today's video is to make zinc hydroxide. Zinc hydroxide is a white powder that is sparsely soluble in water. We can leverage that fact to get what we want. In one flask, I have zinc chloride. In another flask, I have sodium hydroxide. These two will react in a reaction called a double displacement. A double displacement is called a double displacement because it displaces the metal ions in both salts. Here is a visualization of that. We have this AB salt and CD salt. These A and C swap, leaving you CB plus AD. In our case, AB is zinc chloride and CD is sodium hydroxide. Now there's two equivalents of sodium hydroxide just because zinc bonds twice, so it needs two hydroxides. And in that case, then you get two sodium chlorides out. That's a byproduct. We don't want that. Luckily, sodium chloride is soluble in water. This isn't soluble. So we can leverage that to get what we want, which is that, by just washing it with water to get rid of that. Sodium chloride is just table salt. So now we take a reaction flask and pour in one of the ingredients. We're going to be pouring in, this is the zinc chloride. Okay, good. Now we're going to take this. And as soon as we pour it in, you should see white. And now you can see how it's totally insoluble. It's just this clump. Now, we want to make sure all the sodium hydroxide is used because a fun fact about zinc hydroxide is that its solubility in water changes as the pH changes. So we don't want a low pH, we don't want a high pH, we want it in the middle. So you can see I just rubbed on some paper. It's in the middle. Good. Very good. So now we have all this. And now we have to do some water washings, and then we filter it off and get what we want. Okay, now I made some extra. There's quite a lot here. And it's filtering out. That's all salt water right there. And then, here we go. We're just doing a vacuum filtration. As you can see, and that's plugged in. And we're just stirring this every now and then so it doesn't settle and get stuck and it'll take forever. And we're just filtering out all the salt water. So we're left with our insoluble product up here. Here is my zinc hydroxide. I filtered it. Most of the water's out. It's still a little bit damp. I pressed it between two paper towels, so that's why it looks how it does. And between each of the paper towels, I put some Kim wipes, which are like dust-free paper towels. And just so I don't get any lint or dust inside this. But then on the other side of the Kim wipes, I put some just normal paper towels because they're more absorbent. So if this doesn't come in contact, but the water can seep through, that's kind of the idea. Now, I have to dry this. Now, you might just think to put on a hot plate, but if you do, then you're not going to get your desired output. This is all zinc hydroxide. If you put on a hot plate, it will kind of boil off a water molecule off that. So zinc hydroxide is two oxygens and two hydrogens. If you heat it up, two of those hydrogens and one of those oxygens is going to migrate off, and that'll just leave you with zinc oxide, which is different. It has its own uses, but it's not what we're trying to get today. So we won't do that. If we ever need it, though, we'll just take this product and heat it up. Here's the final product. It is a nice, fluffy white powder. I grinded it down a little bit to make it a tiny bit finer.